Hello friends, welcome to video lecture on measures of central tendency, which comes under CPT section D, quantitative aptitude, statistics part, chapter 11. Myself, Dr. N.V. Ravi, I am mentor for this session. In this session, we are going to discuss importance from real life and examination perspectives of this topic. An average of 3 to 4 marks in the CPT section D quantitative aptitude will cover. Friends, now we are going to discuss on the topic measures of central tendency. Before discussing this topic, we have to know about what is learning objectives of this topic. To understand different measures of central tendency, arithmetic mean, median, mode, geometric mean, and harmonic mean, and computational techniques of these measures. Second, to learn comparative advantage and disadvantages of these measures, and therefore which measure to use in which circumstances. Now, coming to the types of central tendency, let us see one by one. We are going to discuss in the different parts. In this context, first we are going to discuss, friends, now we are going to discuss various types of measures of central tendency. Let us see one by one. One is arithmetic. Now we are going to discuss various types of measures of central tendency. See one by one. One is arithmetic mean. Second one is median. Third, mode. Fourth, geometric mean. Harmonic mean. We discuss in the forthcoming slides each one of the measures of central tendency. Let us see each categories one by one. Before going to discuss about the measures of central tendency, what are the properties which should be ideal measures of central tendency? The properties such as we are taking into criteria as follows. It should be properly unambiguously defined. It should be easy to comprehend. It should be simple to compute. It should be based on all the observations. It should have certain desirable mathematical properties. It should be least affected by the presence of extreme observations. These are the criteria before using the various measures of central tendency. If they follow these criteria, we can say that they are all ideal measures of central tendency. Now coming to the discussion of these measures of central tendency, now we are going to discuss about the arithmetic mean. Arithmetic mean may be defined as the AM, or simple way it is called mean also, and generally we call mean also arithmetic mean. In formulae we can denote as the symbol x bar. It is the sum of all the observation divided by the number of observations. Thus, if a variable x assumes n values, x1, x2, x3, etc. xn, then the AM of x be denoted by x bar. It is denoted by x bar. It is giving in the symbol x bar equal to x1 plus x2 plus x3 plus x4 plus etc. xn. That is in simple form. That is here, this is summation of I takes value 1 to n values xi by n. In other way, it is sum of the observations by number of items also in simple manner. This is the formula for simple arithmetic mean for individual series. For individual series, we call it as the formula will be used. It is called individual series, or we can say that this is raw data. In case of a simple frequency distribution relating to an attribute, suppose the data is the heights and weight of the students or number of students we measure in different way. In the classroom, therefore we have different height students, number of students are there. We want to find the average height of the students. We apply it is called the frequency distribution, simple frequency distribution. In that case, the x1 into f1, x2 into f2, x3 into f3 plus etc. xn into fn by the sum of the frequencies, which is mentioned in x bar equal to summation of fi xi, I takes value 1 to n, summation of fi. This is called the average or simple mean. In the case of discrete, we called as in terms discrete series. It is called discrete series, or the data is discrete series means it is having the observation values, respective frequencies are also given. Such case we use the formula, that is x into f, x1 into f1, x2 into f2. This is called simple frequency distribution. A may be computed in the case of grouped frequency distribution, that is by assuming some formula d equal to xi minus a by c, that is x bar equal to a plus summation of fi di by summation of fi into c, where c is class length of the class interval, and a is assumed mean. Suppose the class interval series is given in the data, and it can be taking by the mid values, that is by called x values. Suppose 0 to 10, 10 to 20, 20 to 30 frequency has been taken. In that case, 0 is called lower boundary of the class interval and 10 is called upper boundary of the class interval. We have to take the mid values, lower boundary plus upper boundary by 2, that is 5, and lower boundary plus upper boundary by 2, and lower boundary plus upper boundary by 2, that is 25. We assume that 5, 15, 25 are the x mid values. Then based on the mid values, the d value can be calculated at d equal to xi minus a by c. That is, suppose we assume that a is the assumed mean, and then it will be 0, that is 15 minus 15 by class interval length is 10, it is minus 1, it is plus 1. After that, suppose frequencies are given here and we calculate fd values, and then summation of AA plus summation of FD by summation of F into length of the class interval. While calculating this formula, we use the deviation values. Hello students, now we are going to discuss the examples of computing arithmetic means. Now coming to the first example, following are the daily wages in rupees of a sample of 9 workers, that is 58, 62, 48, 53, 70, 52, 60, 84 and 75. Now we have to compute the mean wage. Here the data is the individual series. Now we have to compute the average wage. Average wages we have to compute. Before that, we have to see the observations as follows. X1 is 58, X2 is 62, X3 is 48, X4 is 53, X5 is 70, X6 is 52, X7 is 60, X8 is 84, X9 is 74. We all know the mean for the individual series X bar equal to, it is sum of the observation X1, X2 plus up to X9 observations by 9. Another way, summation of X by N. Here, if you sum up all the observations, that is 58 plus 62 plus 48 plus 53 plus 70 plus 52 plus 60 plus 84 plus 75 by 9, this will equal to 562 and 9 observations, which is equal to 62.44. So for the given data, the average wages for the workers is rupees 62.44. Now we are going to compute the mean weight of a group of BCom students of a college from the following data. If you look at this series here, which is discrete series, here weight in kgs, like it is in the series given 44 to 48, 49 to 53 kgs, 54 to 58 kgs, and 59 to 63 kgs, 64 to 68 kgs, 69 to 73. Respective number of students are also given here. And this is the example in the case of discrete series. Respective class intervals and number of students are also given. Already we have discussed in the case of discrete series or frequency distribution how we can compute the mean. By taking the mid values for the given data, that is class intervals, we assume that mid values are x, like x, and mean equal to, in the case of frequency distribution, summation of fx by summation of f. This is the, in the case of frequency distribution, when mean can be computed based on the mid values, this is an average formula. Keep it in mind. We have to compute in the next slide how the mid values can be calculated also. Now, the data 44 to 48 and 49 to 53, 54 to 58, 59 to 63, 64 to 68, 69 to 73. And respective number of students are 3, 4, 5, 7, 9, 8. Generally, in the calculation of the mean, the sum of the frequencies is very important. So, the sum of the frequencies is, if you sum up 3 plus 4 plus 5 plus 7 plus 9 plus 8, which is equal to 36, and mid values can be computed as follows. We assume mid values are xi, that is 48 plus 48 by 2, which is equal to 46, 49 plus 53 by 2, which is 51, and 54 plus 58 by 2, which is 56, and this is 61, and this is 66, this is 71. There is no need of calculating the sum of the, here the column is the total values. The other important calculation in this formula is sum of the frequencies, the respective frequencies is multiplied by mid values. 46 into 3, 138, 51 into 4, 204, 56 into 5, which is 280, 61 into 7, 427, and 66 into 9, 594, and 71 into 8, 568. The sum up of all the items, which is equal to 2211. In the next slide, see, by using the earlier table values, x bar equal to summation of fi xi by n. The n is nothing but sum of the frequencies, which is equal to 36, and already we have found in the earlier table the xi values are 2261 and n value is 36. By dividing this, we get 61.42 kgs. This is the average weight of the students. Students, friends, in earlier slide, we have computed the arithmetic mean based on the frequency distribution. Now coming to the problem, which is also based on the frequency distribution as well, but here we are computing this example based on the deviation method. Let us see this example. Here the class interval and frequencies are given. The class intervals, the example is, the class interval here is inclusive class interval series. The class intervals in the case of that one is inclusive series and another one is exclusive series. These are the two types of the class interval series. Now we are coming to the discussion of the inclusive class interval series. This inclusive class interval series, the data are 350 to 369 and frequency is 23. 370 to 389, the frequency is 38. 390 to 409, 58 frequency. 410 to 429, 82. 430 to 449, 65. 450 to 469, 31 is the frequency, and 470 to 489, 11 is the frequency. Now coming to the point of discussion related to inclusive class interval series. In this case, both the values from these points, the lower boundaries and upper boundaries are also included. We call as this is lower boundary, this is called upper boundary. In the case of exclusive class intervals, these are not included. Now, using the deviation method, we have to assume after converting these class interval classes into mid values, and we take some assumed values based on that, that is di equal to xi minus a assumed mean by class interval. This formula we can use for the computing of the arithmetic mean. Let us see how we can compute in the next slide. Here the class intervals are given in the sum is 350 to 369. That is, it includes both the values. So the length of the class interval is 20. This minus this. Next, 370 to 389 and 390 to 409, 410 to 429, 430 to 449, 450 to 469, 470 to 489, and these frequencies are 23, 38, 58, 82, 65, 31 and 11. We need to compute the mid values for this data, that is lower boundary plus upper boundary value by 2. That is, if you sum up this 350 plus 369, that is 719 by 2, that is 359.50. After that, see the data. All the data ends with this series. The difference is the class interval difference is 20 only. If we add 20 to all the things, we get 379.50 and 399.50, 419.50, 439.50, 459.50, 479.50. This is the easy way to computing for the mid values when the class interval length is the same. The length of the class interval is computing by the difference between the two boundaries, lower boundaries or upper boundaries. In this case, it is 20. First we compute the one value, rest of the values by adding 20, then we get the mid values. Now we have to compute the fourth column, that is DI values, which is very important to know the deviation values from the assumed means. This is by DI equal to xi minus a by c. Here we have to assume this 419.50 is assumed mean a, and simply you put 0 respective column. That means these are all xi values. We have to subtract xi minus a, 419 minus 0.50 minus 419.50, by length of the class interval is 20 and which is 0. The upper portion values are decreasing -1, -2, -3 and here the down values the +1, 2 and 3. After that the computation values of Fi and Di values will be simple, that is 23 into -3 -69 and 38 into -2 which is -76 and 58 into -1 -58 and 82 into 0 0, 65 into 1 65 and 35 twos 31 twos 62 and 11 threes are 33. Now we have to find out the values of the summation of frequency values. The summation of frequency values is, if you sum up all the frequencies 23 plus 38 plus 58 plus 82 plus 65 plus 31 plus 11, which is nothing 308, and we have to compute these negative values first and positive values. The negative values are 69 plus 76 plus 58 which is 203 and positive values are 65 plus 62 plus 33 which is 160, and this is negative, this is positive, so minus 203 plus 160, the summation of Fi Di value is minus 43 and sum of the frequencies value is 308. Now coming to the important thing, which is the arithmetic mean, using the formula m equal to a plus summation of Fi Di by n into c. You know, in the earlier slide is a is assumed mean, which is 419.50, and summation of Fi Di is minus 43 and which is 308, sum of the frequencies is n and length of the class interval is 20, and we have to simplify this value 419.50, this will be negative, and which is after simplification this will be equal to 2.79 which is 416.71. So the average for this value is 416.7. Now we are going to discuss based on the example, that is a combined average. The problem is related to combined average. The mean salary of a group of 40 female workers is rupees 5,200 per month, and that for a group of 60 male workers is rupees 6,800 per month. What is the combined mean salary? Students, please note down, the example is related to the combined average. Normally in the examination point of view also, this is very important sum. Now in this example we are going to work out combined average salary of two persons. Two persons means two groups here, that is one is female groups and male groups. Suppose we have two groups 1 and 2 and their average wages also given. In that case combined average formula will be x bar equal to n1 into x1 bar plus n2 into x2 bar by n1 plus n2. Here the 40 is the first group, that is female group, and respective workers average salary, mean salary is rupees 5200 plus, and 60 is the second group, that is male group, that is the 60 into rupees 6800, and total value is 40 plus 60. Now this 40 into 5200 will be 2,08,000, and this will be 60 into 6800, this is 4,08,000, and 40 plus 60 is 100. If you sum up these two values, this is 6,16,000 by 100, which is equal to 6160, is the combined average salary of female and male workers. Students, let us coming to the example related to the missing frequency. How we can compute missing frequency in the data which is related to the average problem. Now the data is as follows. Given the mean height of a group of students is 67.45 inches, and the missing frequencies for the following incomplete distribution of height of 100 students. Here we have to assume that x is the height of the students, and next one is F3 and F4. Here we have to assume these are the mixed frequencies, F3 and F4. If you see, there is an order F1, F2, F3, F4, F5. Now in the next slide we have to compute the missing frequencies. Before that we have to compute the table. Now look at the data which is given in the data: 62, 62, 63, 65, 66, 68, 69, 71, 72, 74. This is the data, and frequencies is 5, 18, F3 and F4 and 8. And mid values we have to assume that as follows. This is the case of inclusive class interval series only. 60 plus 62 by 2, which is 61. By adding 2 here, that is here, by adding 3 here, sorry, this is 64, and this will be 67, and this will be 70. By adding 3, this is 73. Here the difference is between two lower boundaries or upper boundaries is 3. So we are adding these 3 frequencies to all the values. Then we are easily computing the mid values. We assume that A is the 67 is assumed mean value, and the formula is D equal to xi minus A by C. In that case here assumed value is mean is 67, xi minus 67 by the frequency difference is class interval difference is the class interval difference is 3. In that case we have to get this is 0, this is minus 1, minus 2, and this is 1 and 2. There is no need of calculating the sum of the deviations, which is the 0, and there is no need of calculation these total values also, and this is the total which is required is 5 plus 18 plus 8, which is 31, plus F3 plus F4, which is equal to 100. And we need to calculate the Fi di values also. So 5 into minus 2 minus 10 and minus 18, in the 18 into minus 1 minus 18, F3 into 0 0, F4 into 1 F4, and 8 2s are 16. And after simplifying these values, and this minus 28 plus 16, which is minus 12, and plus F4. And in the next slide, we compute the calculation of these values. You know, in the earlier slide, 31 plus F3 plus F4, that is in the sum of the frequencies, is given 100. And from this, F3 plus F4, which is equal to 100 minus 31, that is 69. This is first equation we have to assume. And given that the mean is average is given 67.45, and we have to compute A equal to, sorry, x bar equal to A plus summation of FD by N into C. We have to write like that way, and which is the whole value is equal to 67.45 given. So 67.45 equal to A is 67, assumed mean is here 67, plus on the summation of FD, we have to see that this is summation of FD value is minus 12 plus F4. We have to use that value, and that is minus 12 plus F4 by sum of the frequencies is F4 is sum of the frequencies is 100, and length of the class interval is 3. You know, this value equal to 0.45, 67.4 minus 67 is 0.45, and after simplifying this value, 0.45 into 100, this one, which is equal to minus 12 plus F4 into 3. Then, which is 45, and which is equal to minus 12 plus F4 into 3. From this 3 will come this division, minus 12 plus F4 equal to 15. Therefore, F4 equal to 27. In the earlier slide, we have computed the value of F4 equal to 27. Already we have found in the first equation F3 plus F4 equal to 69. F3 plus F4 equal to 69. And this is by substituting this F4 value in this equation, F3 plus 27 equal to 69. Then F3 equal to 69 minus 27, which is equal to 42. So F3 value is 42 and F4 value is 27. So the missing frequencies are 42 and 27. Hi friends, in this slide we are going to discuss the properties of arithmetic means. Let us look at the slide is very important for the examination point of also. If all the observations are assumed by a variable or constant, say then k, the aim is also k constant. And if all the observations, set of observations or deviation from their aim is 0 for unclassified data. Unclassified with data means the sum of the deviations from respective means is equal to 0. This is a very important property for the MCQ point of view also in the examination. The sum of the deviations from respective mean is equal to 0. It is applicable for both grouped frequency distribution also. That is summation of fi into xi minus x bar equal to 0. Next property, aim is affected due to change of origin and or scale, which implies that the original variable is changed to another variable by affecting the change in origin, change of origin. Say scale, say b, that is of y equal to a plus b, then aim is y bar equal to a plus b into x bar. Now coming to the question time, the MCQs in the topic of measures of central tendency. MCQ 1, measures of central tendency for a given set of observations measures. Number 1, the scatterness of the observation, the central location of the observation, both 1 and 2, and none of these. The answer for this question is measures of central tendency for a given set of observation measures the central location of the observation. The second number one, which is correct for this question. MCQ 2, while computing the arithmetic mean from grouped frequency distribution, we assume that the classes are of equal length, the classes having of equal frequency, all the values of classes are equal to the mid values of the class, and none of this. Here the question is, while computing the arithmetic mean from a grouped frequency distribution, we assume that all the values of classes are equal with the mid values of that class. This is the correct answer. Third one is the correct answer for this question. Next one, which of the following statement is wrong? Mean is rigidly defined. Second, mean is not affecting due to sampling fluctuations. Mean has some mathematical properties. For all of this, the correct answer is here, mean is not affected due to sampling fluctuation. Next, which of the following statements is true? Usually mean is the best measure of central tendency. Usually median is the best measure of central tendency. Usually mode is the best measure of the central tendency. Normally GM is the best measure of the central tendency. Among all these measures, mean is the best measure of central tendency. The most commonly used measures of central tendency is first AM, second median, third mode, fourth both GM and HM. The correct answer is AM. Weighted averages are considered when, number 1, the data are not classified. The data are put in the form of grouped frequency distribution. Third, all the observations are not equal importance. Fourth, both 1 and 3. The weighted averages are considered when all the observations are not equal importance. This is the case for weighted average used. Third answer, the third option is correct. If there are three observations 15, 20 and 25, then the sum of the deviations from the observations of their AM is simply by using the property sum of the deviations from the respective mean is 0. So in that case there is no need of computing this problem. The answer is 0. And second, 5 minus 5, none of these are all not applicable. So option A 1 is correct. If there are two groups containing 30 and 20 observations and having 50 and 60 as arithmetic means, then the combined arithmetic mean is option A, option 1, 55, option 2, 56, option 3, 54, option 4, 52. Now, we have to compute the combined average. You are all aware of that combined average equal to n1 into x1 bar plus n2 into x2 bar by n1 plus n2. Here, the first group is 30 into 50 plus 20 into 60 by 30 plus 20, which is equal to 1500 plus 1200 by 50, which is equal to 54 is the correct answer. This is an important sum. Just look at this MCQ. The average salary of a group of unskilled workers is rupees 10,000 rupees, and that of a group of skilled workers is rupees 15,000, and the combined salary is rupees 12,000. Then what is the percentage of skilled workers? Here options are A 40%, 2 50%, 3 60%, and 4 none of this. Now we have to compute the percentage of two workers. We have to assume that X, let X be the skilled unskilled workers and Y be the unskilled workers. And in that case, using the earlier formula, the 10,000 into X plus 15,000 into Y, and this is combined average is 12,000 into X plus Y is the combined. Like that way we have to proceed. And if we take common 1000 divided by 1000, it will be 10x plus 15y equal to 12 into x plus y. 10x plus 15y equal to 12x plus 12y. And this would be 3y equal to 2x, and x is to y equal to 3 is to 2. In that case, we have to compute the percentage of skilled workers. Here this is x is unskilled and y is skilled workers, which is 2 by 5 into 100, which is 40%. Students, look at this sum. The sum is calculated based on the formula n1 into x1 bar plus n2 into x2 bar by n1 plus n2. Here we are assuming that the number of persons and the unskilled person is x and skilled persons is y, and in that way 10,000 into x plus 15,000 into y by x plus y, which is equal to 12,000. We cross multiplied. After that we got this equation in the simple form. So this is a multiple choice question examination pattern. So we have to get the results very quickly, and we got this equation immediately after computing this. Then we divide the whole thing by 1000. This we got the expression into ratio format, and we need to compute the y ratio scale to ratio in terms of whole. That is total 5 points, 2 by 5 into 100, which is 40%. Now, MCQ 10. If a variable assumes that values 1, 2, 3, 4, 5 with the frequencies as 1, 2, 3, 4, 5, then what is the value of arithmetic mean? Number 1, 11 by 3, 2, 5, 3, 4, and fourth option 4.50. Now we have to compute the arithmetic mean using the formula. Here x values are given, frequencies are also given, 1, 2, 3, 4, 5 and 1, 2, 3, 4, 5. We need to get the value x bar equal to summation of fx by summation of ff. The summation of fx value is 1, 4, 9, 16, 25 and which is 55, which is 15, 55 by 15, 5 3 is 511, 11 by 3 is the average for this, the sum, the numbers 1, 2, 3, 4, 5. Option 1 is the correct for this question. Students, with this I have been completed the topic arithmetic mean. I hope you understand very well for this topic. Thank you very much.